Now, lithium can be accessed in two types of places, right? Firstly, in a substance called brine, right? And number two, in hard rock, right? When we look at the hard rock methods of extraction, it's basically the normal mining methods that we have come to know, basically mining the lithium through open cast methods or underground mining, right? Through dynamite, basically drilling holes into the ore and putting in dynamite and then basically blasting out the ore and processing it, right? So that's the hard rock extraction methods, right? Brine is a mineral rich chemical concentrated mixture, right? That is formed over 1 million years. The way it is formed is that when rain comes down on the mountains, right, it flows down to the valleys, right? And in the way it collects a lot of minerals, right? When it passes through different types of rocks, right? And it collects all of these minerals, right, and chemicals, and then deposits it in something called a salt flat, right? And this salt flat contains a lot of brine, right, chemical mixture or mineral rich substance, right, in which various minerals can be extracted from it. The way you extract minerals, right, using the brine method, right, is firstly, you need to drill holes, right, that will reach where the brine is found, right? And then you pump up this brine towards the surface, right? And then pump it into something known as evaporation pools, right? This is where you allow the brine, right, to sit in the pools, right? And to basically evaporate, right? Now, the more evaporation occurs, the various chemicals, right, and minerals can be extracted from it. And mostly, this brine method of extraction is used in particularly the South America, right? In a place called the what's it called? It's called the Triangle Lithium Triangle that you find in South America. Now, in South America is where you find the most biggest lithium deposits in the world, right? When you speak of the lithium triangle, right, you are particularly speaking of three countries that are found in South America, right? Firstly, it's Argentina, Bolivia, right, and Chile, right? Now, it is believed that Bolivia, right, has about 20 million metric tons of lithium deposit in that country, right? And when you just look into the next country, right, it's Argentina, right? Argentina is believed to have about 11 million metric tons of lithium deposits that you can find uh, in that country, right? And then if you take a look at another country known as Chile, right? Chile also is believed to have about 11 million metric tons of lithium deposits which are available there, right? Now, these three countries are the ones which are actually form something called the lithium triangle. This area of the world is believed to supply more than half of the world's demand of lithium, right? Now, South Africa is not a lithium rich country, right? But it is believed that South Africa has about 250,000 metric tons to about 400,000 metric tons of exploitable or recoverable lithium, right? All of this can be found in a project known as the Blesberg Lithium Project, which is based in Northern Cape. But the one thing that South Africa can bring to this market, right, is their a capacity to manufacture end products, right? As we all know, South Africa has an ability to manufacture high quality products, right? And they can use the lithium which is found around the region, right? Particularly south of the equator in the landmass of Africa, use all of the lithium that is found in that region and process and manufacture lithium-based battery products. Namibia does have a huge amount of lithium deposits that can be found in the country, but the lithium deposits that you find in Namibia is of low grade, right, or of low quality ore. Now, on average, right, the quality of ore of lithium ore that you find on average in the world stands at about 6%, right? But in Namibia, because of its low grade or low quality ore, the lithium that is available stands at about 1%, right? So lithium is available, right, in Namibia, but it sits in a lithium ore that is of low quality, right? Now, it is believed that Namibian lithium ore or lithium deposits, right, sit at number 4 in Africa, right? So it basically means that Namibia has the fourth largest, biggest lithium deposits that you can find in Africa. The Democratic Republic of Congo is believed to have about 3 million metric tons of exploitable and recoverable or commercial grade ore. And yes, Zimbabwe, right? It is believed that Zimbabwe has the sixth biggest lithium deposits that you can find in the world, right? But it sits comfortably at number 1 in Africa, basically meaning Zimbabwe has the biggest lithium deposits that you can find in Africa, right? Now, it is believed with the amount of lithium that you can find in Zimbabwe that they are able or they can be able to supply 20% of the lithium market. Now, there's a mine in Zimbabwe that is known as Bakita Mine, right? This is a Chinese owned mine, right? Now, it is known that this mine has about 11 million metric tons of lithium available to supply the market. In 2020, Zimbabwe decided to ban lithium exports and encourage anybody who wants to invest in the lithium industry in Zimbabwe that they must build a lithium processing plant in the country in order for them to access the lithium, right? I am glad to say that a Chinese company took on the challenge and built a uh, 300 million US dollars lithium processing plant. And let's remember that the Chinese account for about 70% of the EV battery market, right? So 70% of the EV batteries that you find on the planet are produced in China. There are two types of lithium ore that is available for mining, right? Number one is known as the spodumene, right? Ore, right? Which basically is a lithium ore which contains about 6 to 7% of lithium in it. The second type of ore that you can find is known as lepidolite, right? Lepidolite ore, right? Which is basically an ore which contains about 1 to 2% of lithium. When you actually process these two types of ore, right, the result of this processing, the first stage processing, right, the result that comes out, right, the substance is known as a pigmentite lithium. And with the second stage processing of this lithium, pegmatite lithium, right, then you can produce two types of products, which are actually the raw materials in which you put or create a battery, right? The first type of substance that you can get after the second stage of processing is known as the lithium carbonate, right? Which has a melting point of about 723 Celsius degrees. The second type of product or substance that you can get after the second stage of processing of this pigmatite lithium, right, is known as the lithium hydroxide, right? This lithium hydroxide has a melting point, or rather a boiling point of 420 degrees Celsius, right? Now, these two substances, right, the lithium hydroxide and the lithium carbonate, are the actual raw materials, right, which actually create the cathode side of a battery,